We present dynamic neural radiance fields for monocular 4D facial avatar reconstruction. Given a monocular video stream of a talking person, we reconstruct a volumetric representation of the facial appearance and dynamics. Specifically, we propose a hybrid between a scene representation network and a low-dimensional morphable face model, which gives us explicit control over pose and expressions. This also allows us to transfer the expression and pose of a different person to the 4D facial avatar. Our scene representation network stores the radiance field of the scene, including per point colors and density values. An image of the scene is generated using volumetric rendering by casting rays through each pixel. Along the ray, the radiance field is sampled and the color and density values are accumulated to compute the final color of each pixel. By placing the camera at different locations, images from arbitrary positions can be rendered. A scene representation network is trained by minimizing a photometric reconstruction error between rendered and ground truth images. In our case, these training images are captured by a static camera, such as a webcam. Given such an input sequence, we employ a face tracker to embed our scene representation network in canonical space. While the tracking of the head pose is used to transform samples from the casted rays to the canonical space, the background is decoupled from the head pose and cannot be properly reconstructed within this representation. Thus, we leverage a single snapshot of the background taken before the subject enters the frame. The background-foreground separation is learned implicitly. To account for the non-rigid dynamics of the face, we make use of the low-dimensional blend shape coefficients of the morphable model-based face tracker. For each frame, the dynamic radiance field is conditioned on the expression parameters. This allows the network to adapt the geometry to the current frame by continuously altering the density values at each point. While the rigid head pose and the expression vector account for most of the dynamics in the scene, some parts, such as the shoulder articulation or tracking errors, remain unparameterized. To address this, we introduce a learnable latent code for each frame in the training set. At test time, we feed in the latent code of the first training frame. The latent codes enable higher perceptual quality and sharper images. Our approach is able to reconstruct an implicit 4D representation of a talking human head with semantically meaningful handles for pose and expression. Our dynamic radiance field is able to learn the volumetric deformations and the surface that corresponds to each facial expression. To demonstrate this, we use the expected ray termination depth to render normal maps of the scene's geometry. Since our method does not rely on any proxy geometry, objects like eyewear and hair, which are typically difficult to reconstruct, are also captured by our approach. We quantitatively and qualitatively evaluate our method on the task of rendering the captured avatar under unseen poses and expressions. In order to have ground truth data, we apply self-reenactment and hold out a test set for each sequence. While numerous methods for face reenactment exist, few methods exist that allow control over both expression and head pose. We compare against first-order motion models and deep video portraits. First-order motion models, which only uses a single input image, fails to preserve the identity and suffers from warping artifacts. Deep video portraits produces artifacts for large head rotations and produces an unrealistic mouth interior. In contrast, our approach produces a sharper mouth interior, captures the view-dependent effects better, and enables larger head pose changes, while still maintaining temporal coherence. As the expression parameterization is global, we are able to perform cross-subject reenactment where we transfer both the pose and expressions from one source actor to the 4D avatar of a target actor. Thank you for watching.